welcome back to the second class. Like I said, next week onwards, we'll be meeting in separate sections. Tuesday, who are supposed to be showing up? Undergrads. Okay, if you are registered for 494, you should show up on Tuesdays, and grad students should show up on Thursdays. Like I said, if you really want to hear it twice, you can show up both classes, but on Tuesday, I would basically mostly be focusing on questions that undergrads have and discussion that is pertinent to them, and on Thursday, grad students. Okay, both of you would have watched the same exact video lectures before coming to the class. The lectures that you are going to watch for next class, the next week basically, are lectures L4 and L5. And specifically, these are the numbers here. Okay, L4 and L5 are the ones that you will be watching. And as I said, one of the mails I sent, it's all on YouTube anyway. And so rather than, there was a question as to if you have questions on specific things that were talked about in the lecture, where do you post them? You can post them on Piazza, of course, but I think we may as well use the comment facility on the YouTube. I think that way you can also actually specifically point out the time. Right? Basically, if you go somewhere, I guess it'll tell you, what is the minute and second part, and you can, post it with respect to that. Okay. So that's regarding the lectures that you're going to watch for next week, and the readings that you would have, that you can do in the background for those lectures are essentially those chapters. It's okay to first watch the lecture and then read. That would be completely fine. Okay. But if you have all the questions you have about the lectures, we'll be discussing them. If they're minor ones, I'll just probably answer them online. And if there are bigger ones, we'll discuss them in the class. Okay. That's sort of what we will be doing. Any questions on that part? Okay. So, in today's class, which is the second of the introductory classes, and so we will be starting next week. Basically, we'll be doing the technical material for the course. In today's class, the three pieces that I plan to do are, the first we will sing praises of structure. Structure is very important. We'll understand why structure is important. You may not particularly appreciate how much ever I sing praises of it today. You may not particularly appreciate it today, but hopefully by the end of the semester, you will be like that person singing praises of structure. If you don't have structure, you'll get some, okay, because it's very, very useful. And then we will talk about how this course essentially can be seen as a cross-cutting course, which brings several different disciplines: information retrieval, social networks, databases, and machine learning to the web. So they all existed before the advent of web, but there are new web-induced headaches that you need to take into account. Okay, information retrieval existed as a discipline before web became popular, and then similarly, social networks existed, databases existed, machine learning existed. Okay, and what we are going to look at is how do these things, and what are the interesting new problems that web creates to each of these disciplines. And understanding that is to some extent what happens in this course. Okay? So you will get an idea of that, and to some extent in the actual course itself, we will start by discussing information retrieval, and then discussing how we'll bring information retrieval to web. That's the first 2 or 3 weeks. And then we'll talk about, in fact, part of that would be, we'll also be talking about social networks and how that sort of leads to things like PageRank and authorities hubs ideas on the web. Okay, and so on and so forth. We'll do some for mining, data mining, which is basically machine learning for the web, and databases. Okay. That's the second part of today's course. So explaining to you that this is what we'll be doing is the second part of today's lecture. And the third part of today's lecture are essentially a bunch of big ideas in big quotes that I want to throw out as cross-cutting ideas across the course. And hopefully you will come up with more of those over the course of the semester. That is sort of interesting in their own way, and it sort of hopefully bring out what sort of work is most useful in this sort of scenario, in the scenario of doing retrieval, mining, and integration on the web. Okay, of course, I'll make more sense of it when we actually talk about the big ideas. Okay, so that's what I am planning to do today. Okay. Structure. So last time we started talking about it a little. So let's think about the following three kinds of things: a generic web page containing text, okay, and an employee record. I drew some picture of a database record of an employee, so an employee record, and a movie review or an email message. These are three different kinds of documents. Okay, I want you to kind of think about the differences between them. And presumably, this one is in normal English. It has a lot of structure for people who know English. Okay, actually, it has lots and lots of structure. There's very nuanced things can be written in generic web text. But for a program that does not understand natural language, it's just a bunch of words. Okay, so from the point of view of programs that try to do word-level analysis of files, this has barely any structure. So it's like a very weird thing to say. We always will say web pages are unstructured. So all your life, whatever you're reading, it's all unstructured, including the papers you read for this course are unstructured. Okay, but we know more. In fact, we basically know that if I were to give you a database format of this course, it would be boring as hell. Okay, there's a lot more that you can write in English as text, right? But if you in fact one of the things we'll see later on is if you are reading some document in a completely different language, which let's say Thai. Are there any Thai speakers here? No. Okay. So if I give you a big file of written in Thai, it's unstructured. It's we say gobbledygook. It makes no sense to us. Then if I somehow say, by the way, from here to here, it's the name of the person. From here to here, it's the educational qualification of the person. From here to here, it's their employment history. Suddenly you feel you understood something. Oh, this must be the CV of one of these Thai people. You don't really understand what a Thai speaker will understand, a Thai native Thai speaker will understand, but you know a little more than you had before, because before it was all just gobbledygook. And this is exactly what happens when you give an English file to a program which doesn't understand English. Okay, and so if you can, so basically this whole course, of course, would be completely useless when we figure out how to do natural language processing automatically and efficiently. So it's one of these intermediate courses. You'll get your jobs and you'll live happily for a couple of years, and then somebody will figure out how to do natural language processing efficiently, and you won't have a job. Okay? So basically, but right now we still don't know how to do full-fledged natural language processing efficiently because it's an AI complete problem. It's the hardest problem in AI. And AI complete means CS complete, because any hardest problem in AI is also the hardest problem in CS. So for them, with respect to what we can do currently, these are unstructured. This is fully structured. An employee record has columns, and each column has a name, and you know the domain from which the column values will be taking. A lot more structure. A movie review is semi-structured. It has some pieces that have structure. So for example, name of the movie, the director name, the actor names, and so on. And plus then the review aspect. The review aspect is completely unstructured. And yet you can essentially process the movie reviews just by understanding some of the structured parts, right? Okay, so if you have these sorts of things, one of the questions is, why does structure matter? To some extent, the indirect message of what I've been discussing until now is, if you know structure, you can answer more interesting queries. Okay, and so this is in English. This is basically, in fact, you can talk about the queries that you can answer on these are typically keyword style queries. Although it's also true that if you know full natural language, then you can answer many more interesting queries on this. So I do want you to understand that sort of dichotomy. On one hand, currently, English is unstructured. But for you, it's not unstructured. Okay? But for your program, it is. An employee record, you can ask queries which are basically arbitrary SQL queries or SQL queries, because any database style query can be asked. Okay? A movie review, you can ask basically XQuery queries. You know, XML is a language in which you can represent partially structured information, and you can ask interesting queries that take both the unstructured part into account. Now that all sounds sort of iffy and wishy-washy. So here are some examples. We'll look at some examples. So structure helps querying. Here are some queries. Give me all the pages that have keywords get rich quick. This is exactly what you get when you type get rich quick to Google. It will give you all the pages which will have get rich quick in them. Okay? That is essentially, you can do keyword style querying. That's the best you can do if you have unstructured text. Okay? Give me the social security numbers of all the employees who have stayed with the company for more than 5 years and whose yearly salaries are 3 standard deviations away from the average salary. Because you really want to know who these deep-pocketed rich people are. Okay? Can you ask this query to Google if you just had written all your history of your company as a bunch of text? Would you be able to answer this question from Google? No. Would somebody like you reading the entire history answer this question? Yes, of course. You can answer any of these questions. By the way, if you cannot answer these kinds of questions, you are in the wrong course. You need to be in how to be a human kind of a course. Okay? It's just that you can answer all these questions. It's just that you don't have the time. You have better things to do in your life than answering these kind of silly questions. You want programs to do. Okay, so that's this one is something that can be easily answered if the entire set of employee records are in some relational database. In which case, you can write like a multi-line SQL query, which will be able to answer this query. It's not even one of the hard SQL queries. In fact, the database queries can be 5-6 pages long sometimes. And they can ask very involved questions. But they're all being done within the context of the columns and the values of the columns and so on. Okay, a third is give me all mails from people from ASU written this year which are relevant to get rich quick. This is sort of in between these two, right? Because this one, the mails from ASU, so to be able to see that these are mails from ASU, you need to know how to tell the from field of the email. But thankfully, emails are already semi-structured, so you know what are the from fields. And then the rest of it, that they are about get rich quick, you just do keyword search. So it's sort of combining both. Okay, so by having partial structure, you're able to answer queries that are more than here. And these kind of queries are sort of in between these and these. Okay. Fourth one is, actually, I'm sorry, I don't know why it went away. A fourth one is the following query. Okay, the fourth one is, I wrote it this, I'll write it down now, I'll tell you now. The explorer Magellan went around the world, sailed around the world 3 times. And one of those trips he died. Which trip did he die?
Third. Third.
Thankfully, I'm really happy that you people can answer this. I'm just so happy that I'm not teaching a bunch of computers. But what I want to know is, can your program answer it?
No.
And what would it take a program to answer this question?
NLP.
Do you understand what I'm saying? It's not just that. Even if you just have the structure in terms of columns, okay, the name of the explorer, Magellan, the number of trips, 3, that's still not going to be enough. You need to be able to have some background knowledge. Now, what is this background knowledge going to be? Is this going to say that if Magellan goes around the world 3 times and he dies, he would be dead on the last trip? Is that the way the background knowledge would be written? Is it that if Spanish people go around the world 3 times, and they die, they'll die the 3rd time? Would that be the case? Or would it be saying that if anybody goes around the world 3 times and they die, they will die on the 3rd time? Or is it going to just say that, much more generally, that you don't do anything after you're dead, unless you believe in some major religion? Okay? You don't do anything after you're dead. And going around is considered doing something. And so if you went around the world 3 times, then you could not have died on the 2nd time or the 1st time. So the only thing left is the 3rd time. By the way, this is what you actually did just now. Pat yourself on the back, very hard, okay, because you're so smart. You did all this reasoning very fast. Okay, to be able to do this, you not only have the structure, but once you have the structure, you are essentially putting connections between what you know, such as person name, Magellan. And then the person is a human, and humans die. Death is terminal. All that fun stuff. Okay? So you have background knowledge. And if you have background knowledge, you can answer questions like that. Okay, so to be able to do that, unfortunately, that is one further additional thing where once you have structure, you can connect your structure into the background knowledge of the universe. And then you will be able to answer many more interesting questions than what are just stored in the passage. Many of you have done SATs or GREs, right? Okay, so they give you passages. And the passages hopefully won't have questions like this. Does this passage contain the following word? Although they should ask, given some of the high school students. But then mostly they will ask, based on this passage, do you think that John is feeling a sense of rage or a sense of resignation? Right? Where does it say it? You still answer it, and the test maker knows the answer, and they'll say yes or no, that you got it right or not got it right. But in answering those kinds of questions, you are essentially doing deeper analysis of the passage and connecting it to the background knowledge. Okay, so that's how structure will help you in answering more and more expressive queries. So there is the keyword queries here, and these are SQL queries. These are XQuery or XML style queries, and the one that I was mentioning about Magellan, that is the kind of queries people hope to be able to answer when you have semantic web. How many of you have heard the word semantic web? Okay, so that's semantic web. Okay, semantic web essentially basically should be able to answer all the queries that we can answer, having read a passage. Okay, so that's why structure is important. Okay, now the problem is the following thing. The passage doesn't, the SAT passage that you read, SAT or GRE passage that you read doesn't have structure. You know what the structure is. That's why you get points. Critical reading is understanding the passage, converting into internal structure and answering queries. Okay, that's what you are able to do because you can do full natural language processing. Okay, but if you don't have full natural language processing, which, it almost looks kind of sad that the entire course depends not on the fact that people don't yet know how to do something. right? But that's true. In fact, how many of you know CAPTCHAs? Have you tried to open any account on Yahoo or anything, and they'll make you say, can you read this piece of text? Can you tell me what is in this image? That too is completely dependent on the fact that we still don't know how to do them automatically by programs. If programs can automatically read, distorted text or see pictures and say that in that picture there is a little doggy, then you basically have to change the captures. So in fact, one of the neat things is for AI and computer science, the stuff that we can't do also are relevant, because the fact that we can't do it can be used to actually tell humans. Our programs can't do it. Can be used to tell humans and computers about it. Okay, but anyway, for now we don't have structure for we don't have the ability to do natural language processing, full natural language processing on the text, although that is changing as we speak, in fact. Okay? But assuming that we don't know how to do much of natural language processing, then how do you get, and you've been given a piece of unstructured text, either you can just support keyword querying, which is what we will do as IR, as the beginning of IR, that's what we'll do. We'll mostly do keyword querying and start going better and better at that. Or maybe the text that is being given to you is given as a data record, in which case, of course, you can do database style query. Or maybe the text that's given to you actually used to be a data record, and they put this into arbitrary English text. In fact, a lot of knowledge, a lot of pages on the web are dynamically generated after the query is sent to them. And they're dynamically generated from a back-end database. This database has structure. But they think humans don't like tables. And they think humans are looking at their databases. So they convert something which has nice structure into a bunch of English. And if you have a program which is looking at it, it actually wants the record directly. Now, if you have paid that site some money, they may give you API access so that you can directly get the data records. If not, you essentially have, let's say something like, if it's a database of, let's say, capitals of the countries, and then you ask capital India, and it might say the capital of India is New Delhi. Okay, and it looks like properly formatted English, and which actually is supposed to be good for humans. Okay, whereas presumably saying something like that, which is just a tuple notation, supposedly is not interesting to humans, but that would be much better for your program. So, if you really want to be able to support automatic querying on that kind of data, then you need to undo what they did supposedly to help you. This is a crazy thing. They had this. They converted into arbitrary English so that that'll make you happy. But you actually are annoyed that they made it into English. You need to convert it back to this. That is called actually, that's sort of your unwrapping. So they took this, wrapped it into some pseudo-English, and you need to unwrap to get this back. For whatever reasons I can't explain, that is called wrapping. Okay, so this unwrapping thing is called wrapping, and so you write wrapper programs which basically look at what is on the screen, convert it back into a record, and then put it in a local database so that you can do local database style query. That would work well if in fact the original data has very strong structure and it was just lost because of this unnecessary wrapping. So you can unwrap. Okay. And in fact that way there is a lot of structured data already on the web, and it's being essentially just disguising itself as arbitrary pseudo-English, and you can get it back to normal structured data, and you can at least do SQL query. I want you to feel good about SQL. If in general, in many other courses, people will think, database style querying is probably the least common denominator. You should do much better. But in IR, database style querying is out here. Why? Because what you're mostly doing in Google and all the search engines is keyword querying. You cannot answer the SQL style queries. So even getting there is good. And then after that, you can get to the Magellan style queries. That will be even better. Okay, so either there used to be structure and it was lost, so you can get it back by unwrapping it. Or there never was any structure originally, and you really need natural language processing techniques to get the structure out. Okay, in that particular case, essentially, even though you may not know full natural language processing, there are still ways of doing partial processing of text. And that would bring out some of the structure of the text. Okay, so in some sense, actually, part of what we are saying here is that IR is NLP light. Okay, information retrieval is what people do when they don't know how to do full natural language processing. And thankfully, nobody yet knows full natural language processing, so you can do this course. Okay, fine. Now that's one way. And in fact, there is a name for it. If you're doing this, you make up a name. It's called information extraction. That is sort of reading the text and partially bringing out some of the structure. What do you think? You people wrote essays to get into grad school or undergraduate programs, right? Millions of students are writing these essays. They're being very careful about how to write in a nuanced way about their likes and dislikes. And there is this poorly paid admissions officer, right? You think they're reading this and crying buckets? No, they're just saying, okay, this looks like good. Okay, in fact, somebody said that in SAT essays, SAT essays, if it is 2 pages, it must be a good essay. If it's 1.5 pages, not very good essay. Half a page, very bad essay. Okay, so in fact, if Lincoln's Gettysburg Address is written as a SAT essay, it'll only get 3 out of 12 because it's only 270 words, and it'll get over in like the first paragraph. Do you see what I'm saying? But what people are doing is they're looking at this and they're bringing out some little structure. That's better than what you can expect. Do you see what I'm saying? Okay, so that they're doing extraction of information from your essays. And we can write programs that extract information from your essays. By the way, much of this is, it's hard to actually make metaphors that are far enough removed from reality in this course, because as I speak, actually, GRE essays are graded once by the humans and once by the computer. And if you remind me, I will send you a very nice New York Times article that somebody wrote who had access to the ETS essay scoring software. And then he knew how it works. And see, he wrote an essay which will get 12 out of 12. We will read it and fall off, off our chairs, thinking it's such a stupid essay. And it's completely disconnected. But the program basically thinks, hey, it does have enough words. It has enough SAT quality words. And it seems to start with the prompt, end with the prompt, must be good. It's easy to laugh at that, but you have to understand that's way better than just counting the number of words. So between full understanding and zero understanding, there's an entire spectrum. And the more understanding you get, the more useful retrieval and query answering you can do. And information extraction is in that middle ground. You can do that, and we'll talk about information extraction techniques. Okay, so by the way, so first we will just look at no structure and do information retrieval, and then we'll talk about unwrapping and how to improve information retrieval. Then we can talk about information extraction, and we can further improve information retrieval. And another idea for improving structure, when there isn't any structure present, is make people provide structure. Okay? How many of you feel that when you go to a website, they give this arbitrarily long form where you have to fill your information in different boxes?
Why can't I just type my entire information in one particular paragraph? They're just actually using you to fill their database. That's all. You see what I'm saying? When you fill a form, then essentially they know that if it's in this particular box, it must be in this column of the database. In this particular box, it must be in this column of the database. So they're making you fill their database. So you can make people, whoever writes a web page, they should be just like we have DMV, Department of Motor Vehicles, there may be DWV, Department of Web Page Handling. In some countries there already are such things. US is way behind. They don't have any centralized web page handling situation. But if we have one up there, then basically they'll look at your web page and say, no, you didn't put enough background information. You must write it in this format. And you must provide structure behind your page. As crazy as it sounds, that's basically the idea of semantic web. If people voluntarily provide background knowledge about their web pages, so there is a version of the page that humans are supposed to read, there's another version of the page that a program might be able to parse and do better than another program that only looks at the keywords. That's the idea of semantic web. Okay, so you provide, the idea that's typically used a lot in semantic web is this idea of ontology. Ontology is just another name for representing knowledge. Okay, and so you represent your background knowledge, that you represent the knowledge of the page, and there may be other pages which have information about how things in the world are connected to each other, and you are in essence connecting your page text into the overall knowledge, because you are essentially saying, if you wrote, for example, in that Magellan thing, suppose I have Magellan went around the world, blah, blah, blah. So I might annotate and say Magellan person, or maybe actually explorer. And then there is a background ontology somewhere else which says explorers are humans are mammals, and so on. So by actually saying Magellan is an explorer, you somehow connected it into this bigger ontology, so you may be able to bring to bear all that background knowledge in answering queries about this page. This is how you answer queries. This is how you answer passages. You don't just answer passages by just looking at whether or not a particular word is present in the passage. You bring to bear the entire background knowledge you have, which is why you do SAT when you are in high school, not when you are in first grade. Okay? So this is the semantic web idea. And in fact, if the semantic web hopes that if you show to people, of course they're still not saying that US should become dictatorial and not let random people put up web pages. In fact, one of the biggest problems in web is any random person can put up a web page. Now I'll turn it around and say, one of the only reasons web is interesting is because any random person can put a web page. If only, in fact, there's a beautiful saying by Henry David Thoreau, that if only the birds that sing the best sing, woods would be very quiet indeed. Okay? If only the birds that sing the best sing, then it would be very silent woods. The reason web is what web is because any random person can expound on any random thing. If we have to kind of certify everything, there'll be 18 pages for the web, and we don't need this course. Okay? We can just have a poor employee read those 18 pages and say what is in it. Okay? So semantic web basically hopes that people will put this background structure on their own accord when they see that by doing this connection, the other people, other programs can use these pages much more effectively. So they provide some sort of a commercial interest or an economic interest, rather than say the government will put you in jail. Although that aspect is also being used in certain other countries. Okay? So that's the semantic web idea. At small level, for specific industries, this idea is already done. Okay, in fact, when I say information extraction, you know, a lot of you know Pandora, right? Right, in Pandora, basically, you are listening to a song and then it will show you all other songs that are related to it. How is it doing it? It basically has to know something about this song and how all the other songs should be compared to this song. If you just compare them at the level of the song name, which is completely useless. They need to compare it at the level of internal structure of the song. How do they extract this structure? How do they extract this structure? Do you know?
Maybe from other user activity.
Well, no. Actually, they just hire a bunch of computer science undergrad. No, actually, basically music majors. I'm sorry. They'll hire a bunch of music majors who listen to these songs and write them, you know, classify them in the context of some 300, 400 features. Does it sound very squeaky? I mean, if I were to do it, I'll look for things like, does it sound very squeaky? Is it extremely loud? You know, and things like that. Okay, and there may be more interesting features. And does it sound like country? Does it sound like hip hop? Okay, and then you would write all of these yes, no for each of these songs. Some poorly paid music majors are actually doing this for Pandora. And then when you listen to a song, they don't quite understand what song you're listening to. They know their feature representation of that song. They compare that feature representation to other feature representations of other songs. And so they're able to show you songs that are relevant to you. How did they get it? They extracted the structure. Structure is so important that Pandora would pay people money to extract the structure. But any self-respecting computer science person should essentially write enough programs that eventually the programs will take over the world and they won't have a job. That's part of being a computer scientist. Okay? So if somebody is being paid for doing something, we should write a program such that that won't be needed. It will be done automatically. And for 3 years you will get paid, and then after that, you know, nobody will get paid. Okay? Right? So that's what we'll be doing. That's basically what you know, automated extraction is. You know, currently Pandora is doing human-assisted extraction of features from the songs. But as we speak, there's a lot of work in automated extraction of features from songs. Okay? So that's my big rant on structure. So it's sort of important, you know, and you get by without structure when you are forced to, but you keep hoping for a better day when you have more structure so that you can use better, do better. Okay? That's my first one. Any questions on that? Yes.
There was something like invisible web that disguised itself.
Yeah, so the invisible web basically is a database which is essentially sitting in the back end, and when you send a query, so there is this idea of surface web versus invisible web. Surface web are basically a set of pages which have direct URLs. An invisible web is a single page with a single URL with a huge with a huge database in the back end. The database has probably 1 billion records. Each record itself is a separate URL, but you don't have access to it. What you do is this page, you send your query to this page converts your quote-unquote keyword query into a SQL query, sends it to a database sends the record, it converts it into English, shows it to you with a temporary URL. That's the invisible part of the web. And there is an assumption that there's a general understanding that the invisible part of the web is much larger than the visible part of the web. Okay, because there are large numbers of databases that are all sitting in the back as backends of various pages. And so, in fact, that's why unwrapping techniques are important, because you can then use that, those kinds of techniques to also answer questions that can only be answered by essentially using those databases.
But Professor, isn't that the three-tier architecture?
What?
Invisible web. It's like the three-tier architecture, because you key in the keyword or something, and then it gets converted into another format. using your SQL, and then you transfer it to the database which is at the back end.
So what is the point?
So I mean, like, isn't that the invisible web? Like,
I mean, I don't know. I mean, if you're giving a different name to what I just said, yeah, that is fine. Okay, but saying it 3 times still leaves open the point that those records don't have URLs. One of the things we'll learn about is obviously the way web search engines work. Not obviously, even you'll know it very quickly enough if you haven't heard about it before, is that they will crawl pages and index them. How do you crawl pages which don't have addresses? It's very easy to crawl surface web. It's not easy to crawl invisible web. Invisible web gives all sorts of interesting problems. Okay, so you should know that it exists and how to handle it. Okay. Okay, any other questions? Okay, the next part I want to do in the next 15 minutes, very quickly, because this part really is the course, and so I just want to give you an idea very quickly. That if you were to talk of where are the techniques in this course coming from, essentially I could say that there exist traditional disciplines called information retrieval. You can take a course just on pure information retrieval. Okay, social networks, you can just take a course on social networks. In fact, it has nothing to do with Von Lu's course on social networks. Okay, social networks existed before. We are social creatures. Okay, we all cared about things like who is the most popular kid in the high school was decided based completely on social network analysis. Okay, so the idea of the discipline of social networks existed before. The discipline of information retrieval existed before. This used to be essentially what librarians do. Librarians essentially, the reference librarians will take your keyword queries and tell you, look for the following books. And they used to have their own little conference called CGIR, ACM's information retrieval conference. Given how exciting a librarian's job is, as you might imagine, the conference also used to be just equally exciting with 3 or 4 people going. And then web came. And now they can't throw people out. I mean, there's just so many people trying to go to that conference. Because IR became very important, given that essentially web can be seen as a big library. And just as librarian doesn't understand a thing about what is in all the books that are sitting right behind her or him, Google doesn't understand a thing about all the pages that it's crawled. And yet, it can be helpful, just as librarian can be helpful people. Okay? So, that's IR part. Then there are databases which existed, at least ever since computer science has been around, and then that can be useful. There is data mining, or essentially pattern finding in data that existed before web came along. And really what this course is about is how do all these things change because web is there. You want to apply them to web, you can just directly apply them, or you can actually look at what are the specific new challenges that each of them will have to deal with because they are now handling web. So given that, essentially, so this particular slide gives like a very quick overview of the additional challenges that each of them have to handle. And I don't expect you to understand this. If you understand most of it, then you probably know most of what's going to happen in the course of it. Okay? But this is approximately the kind of challenges each of them have to handle. And there is actually a different 4 slides that I'll quickly rush through in the next 15 minutes. Which will tell you on the left-hand side for information retrieval, what is information retrieval? Because I didn't make information retrieval as a prerequisite. I didn't make traditional information retrieval as a prerequisite, so I need to teach you a little about traditional information retrieval. Okay? Traditional information retrieval starts with the problem of if you're given a set of documents and a query expressed as a set of keywords, return a ranked list of documents that you think are likely to be relevant to the user who asked this query. Okay? And then the evaluation, of course, is whether the user feels that the documents that you return to her are actually relevant to her. Now, the interesting thing is that in trying to do this evaluation, if you are not careful, there are 2 different kinds of errors you can make.
you can give documents that are completely irrelevant to the user. Okay? And then you can also you can also miss giving documents that are actually relevant to the user. Those are two different kinds of errors. One is the error of commission, one is the error of omission. And if you're not careful, and if all you care about is just avoiding one of the errors, information retrieval is extremely simple. If you never want to be accused of missing giving one of the relevant documents to the user, that means you don't want to be accused. You want to give a big list, and you don't want to be accused by the user that, by the way, you didn't give me one of these documents that's actually relevant to me. If that's all that matters to you, then anytime people give you a query, you say, here is the library, the entire library. So just give them the entire list of documents. That will ensure that they can't argue that you didn't give them, that you missed giving them one of the relevant results. But in doing so, you essentially also gave them a huge number of irrelevant results. Equivalently, if all you care about is you don't want to be accused of giving irrelevant documents, but you don't really care about giving irrelevant documents much. Then they ask a query, you look at them stone-faced. That's what you do most of the time. Okay, if you speak, then you can be wrong. If you don't speak, then you can't be wrong. Right? That's why classes are extremely silent, because people are making sure that they won't be the laughing stock in front of the other students they think are particularly wise. Here is a little secret. Nobody is wise, including the instructor. Okay? So you should speak. Okay? But by not speaking, you guaranteed that you won't say anything irrelevant. But you also guaranteed that you will say zero number of relevant things. And then there are also other students and other instructors who won't stop speaking. Okay? And by doing so, by droning on and on, they might sometimes tell you something relevant. But then they're also going on giving you a large number of irrelevant things. And you want to separate these two out. And to do that, essentially, we talk about the notions of precision and recall. Okay? Precision is measured in terms of how many results what percentage of the things you said are actually relevant. Recall is what percentage of the relevant things did you actually give. And IR systems are generated to give high precision and recall. By the way, databases also retrieve documents. Databases also retrieve results. Right? And you don't talk much about precision and recall in databases. Why?
Because you have 100% precision and 100%
Because you expect 100% precision and 100% recall from databases. It's a given that you must give 100% precision and recall. Otherwise, you're not considered a database. So given that everybody has to give 100% precision and 100% recall, then how do you compare two databases? Whichever looks cute, in a sense, because there is no difference in terms of the answers they give. So essentially, you'll say, this guy came up with the same answers in 15 seconds, this guy came up with the answers in 14 seconds, so this guy wins. So in databases, performance is what you care about because you assume that ground rule is 100% precision and recall, which actually is impossible to achieve in IR, or actually even in databases, unless you are delusional. And so you really have to consider first the accuracy. Accuracy itself is two-dimensional, precision and recall. The next class, the next week's classes will talk a lot about precision and recall. Okay? So that's what IR has focused on, and they have had some techniques that they have developed. We'll talk about some of them. And what's interesting is when web hit the ceiling, then IR became useful because you can think of web. IR was used mostly in traditional libraries. Librarians would use IR techniques. Lawyers would use IR techniques because law is completely based on case analysis. If a judge ever said something 15,000 years back, which is favorable to you, you go back to today's judge and say, well, they said I can do it, so why aren't you letting me do it now? And it's all about getting the right case that supports your argument. Okay, and so they need to retrieve cases. Law clerks are poorly paid law students, presumably, would go through these cases and bring out the relevant cases and underline the passages that the head lawyer is supposed to present. So in fact, IR systems are used a lot in law. There is an actual system called LexisNexis, not Lexis, which, and also FindLaw, which are proprietary Googles. I mean, it's a retronym in essence, because when these guys existed, Google didn't exist. But from your point of view, they're proprietary Googles for lawyers. Okay, and they do that in a traditional style IR. What's interesting is when the web came, you can think of web as a much larger library, not just a law library, it's everything together. And so the question is, how do you obviously should be able to do IR for web. The interesting challenges are scale. There are billions of documents as against maybe tens of thousands of cases. Okay. The documents talk to each other because they have direct links. Of course, cases talk to each other too, except they'll talk to each other in English. Okay, but web pages have direct links, so any dumb program can follow those links and figure out that this page is connected to this page. So this is kind of negative, this is kind of positive. So there are both opportunities and challenges. The users are bozos. That means you and me. Okay, when we are asking questions, we'll ask any random thing and expect miraculous answers. Okay, you should know what I'm thinking about. Okay, and typically lawyers will ask questions that are like paragraphs long. When was the last time you asked Google a paragraph long question? And don't think specifically of the times when you completely copied the homework question and put it in Google. Because that I know you do. Okay? But normally when you required information, did you ever ask an entire paragraph of a question? And did you not ask because you don't believe Google will understand, or because you are a lazy bum? It's kind of a combination of both. Okay? And so we have bozo users, and in fact, I think some time back they did an analysis and found that basically the mean length, the average length of the queries is 2.1 words. 2.1 words. That's it. And that's why actually now one of the things that these search engines do is even as you type, they will try to give you additional other words. So that, I know we all know that you're lazy, at least just click on one of the sets of phrases we are showing you, so that we'll know more about what you're thinking. In fact, one of the biggest things in IR is, given the disjointed set of keywords that people give, you want to understand what they're looking for, what is their real intent. Okay, and finding intent from short queries is pretty hard, and such a big challenge. Okay, and furthermore, decentralization and lack of guarantees. Law cases were actually decided by real judges in real courts. Library books actually have ISBN number, so that means some editor actually looked at this book and thought it's worth publishing. Web page, you just made it up yourself. So I can make a page saying in big letters, I'm the President of the United States. And nobody, thankfully in the US, I won't be put in jail. If I do it in some other country, maybe I will. Okay, but I can say pretty much anything I want. So if you are looking for the web page of Barack Obama, and I write on my page in the biggest possible letters, Barack Obama's home, and you're doing keyword-based search, why do you think that guy's page is any better than mine? How would your program think so? How do you make your program realize that somehow that is a better page than this guy who's just also saying he will provide Barack Obama? In general, this whole interesting issue of decentralization, no quality guarantees in the underlying data, and yet you want higher quality answers. This is something traditional IR never had to deal with. They never had to worry about the possibility that the book they gave you is talking total nonsense. They only had to worry that the book they gave you is probably irrelevant to you. Now you also have to worry about the fact that the answer I'm giving you is completely untrustworthy. Now one of the most interesting things is relevance is something that you can figure out once I give you the result. Okay, so ask me, let's say, how many years does the giant squid live? And did you hear about this giant squid? They actually got a video of giant squid now. So how many years does a giant squid live? Ask me that question. I'll say apples. That's my answer. And you will see that I'm irrelevant. Okay, I'll say 29 years and 4 months. You have no clue whether I'm right or wrong. I'm clearly saying numbers. You expected a number, I gave you a number. Am I trustworthy? No. You cannot figure out trustworthiness after the fact. You want trustworthiness before the fact. You don't ask somebody to come into your home and start, dismantling stuff and then figure out whether or not they are trustworthy. You want to first figure out whether they're trustworthy and then call them to repair your stuff. Do you see what I'm saying? So trustworthiness, unlike relevance, is something that is extremely important. This was not a problem that traditional information retrieval had to deal with, and had to deal with, and web IR has to deal with it because web is la la land with anybody making pages. So that's, for example, the challenges of the web. And then, of course, there are also some simplifications on the web. It's actually easy to please lay users because you are not paying anything to Google. You can't complain too much anyway. And furthermore, many of you, when you're asking for questions, you have no answer, no idea what the answer is. In fact, people who know the question's answer don't ask that question. Unless they're teachers and that's what they do for a life. Okay, so if you know the answer to the question, why would you ask it? Right? So you're asking questions for which you don't know the answers, and if Google says so, it must be true. And in fact, there are very interesting experiments where people were trying to figure out whether or not Google is actually a high-precision search engine, and they found that people decide whether something is correct or not based on whether Google gives it as the first result or not. So, we basically have lay users, and then it's very easy to place these lay users. Okay? And so consequently, the emphasis would be on precision over recall, first of all, because if you try to give more than, one of the other interesting things is, lay users don't look at more than the first result. Not first page, just the first result, maximum, most of the time. Okay, so giving high recall, giving 10,000 results, all of which are possibly relevant to you, is useless. Giving the most relevant result at the top, most relevant and trustworthy result at the top is much more important. Okay, so that's what you will be focusing on when from a traditional IR point of view. Okay, and then of course, because there are many pages, all your operations have to be ultra fast. And that's where the crawling and the MapReduce architectures, etc. come. Because everything has to be done very fast. Okay, the most critical temporal real estate on the web is the time elapsed after people write their query and hit return and the results appear. It takes more than 3 seconds, people have already left. And you have to do everything fast. So that becomes an important thing. So I did this for IR. Because actually I want to go to the big ideas today before completing the introduction. There are slides for social networks also. I won't do it, just look at it because we'll again come back to them anyway during the course. And in fact, lectures from the last year, the L3, no, I think I said L4, L5 is for next week. The one before that would give more information on this if you're interested. Okay. So that's basically social networks existed before, and then one of the most interesting things is in the past, the social networks existed in a distributed fashion in people's heads. You won't know who your friends are until you ask that friend. Whereas Facebook knows everybody's friends and their friends. And Facebook has a centralized database. So problems that used to be hard in normal social networks become extremely easy in centralized social networks. And also, in the past too, you essentially would use your social network to figure out whether people are trustworthy and reliable and reputable. And you can use this easily available social network of pages to figure out which pages are more reliable, which pages are more trustworthy. You see what I'm saying? Which is again a connection from social networks from the traditional time to social networks on the web. Okay. Similarly, for the information integration, if you had databases, you can always join different tables in the databases to take information from one table, combine it to another table, and then answer queries. Okay, web can be seen as a database. In particular, if you actually extracted the structure of the pages and wrote into little database tables, okay, you have a database then. The problem, of course, is those of you who have any background in databases, you know that each database has a schema, which is the names of the columns. If I give two different people the same job, that is, okay, write a student database, what is the chance that both of them will come up with the exact same names for the column? 0. Okay, and if the column names are not the same, then all bets are off as to how are you supposed to join on columns which have different names. So information integration basically becomes hard because we now have differing schemas, and then of course databases are partially complete. Databases never really are completely correct and consistent anyway. It just was a myth. Okay, now you realize that they are not going to be because you are actually extracting information from text, and your extraction algorithms could have been bad. And so you have to deal with these headaches in joining databases, and that's essentially what information integration is. Okay. And then patterns from the web, you can do lots and lots of things like recommendations based on what you have bought. I can tell you what else you should buy. Based on what you have bought, I can tell you who else might be your soulmate. This is collaborative filtering, recommendation systems, and those can be answered by basically mining techniques on data that existed in machine learning beforehand. What's interesting is oftentimes the training data is not obvious. The training data, there's a large amount of it, but the quality of it is highly suspect. And then the instances are completely noisy and incomplete. This may or may not make too much sense to you. Again, the course is to get you to understand this. So at the end of the course, if you see these 4 slides, you should understand, oh, that's what he meant. So consequently, we will focus on dealing with the additional web-induced challenges with respect to mining techniques. Okay. So that's the second part, very fast second part. I think I did at the right speed for the information retrieval part, but the other things I basically rushed through. Just to tell you that in each of those cases, there is a traditional discipline that existed, and we'll be first understanding that, and then talking about what else do we have to do with it with respect to the web. Okay. So it's more of a breadth-oriented, cross-cutting course. Okay. So the last thing I want to do is sort of get you to think about opportunities and challenges that web provides. Here are 4 things I made up. I would actually love to hear more about these sorts of big ideas that you can come up with, by just looking at what's going on in the course and what's going on the web and so on. Again, as I said, for this course, just reading New York Times often is also a good way of getting more information, because most of the stuff that's going on the web is front page news oftentimes on New York. Okay, not just what's going on in the web in terms of content, but the technology. Most of the technologies we are talking about are being talked about on the front pages of the papers immediately. Okay, so here are a couple of them that I want to mention, and again, these are things that you will probably learn to appreciate more as time goes on, but I want to bring it up right now once. The first idea is finding sweet spots in computer-mediated cooperative work. This is an interesting, long-sounding name, but essentially the reason web search works is because we found a sweet spot that involves computer doing a little part of the work and the human doing a little part of the work. Okay, Google is not answering real queries. It's basically supporting somebody else's interest in answering a query for themselves. And they don't even tell Google their entire query. They just tell snippets of it, which has keywords. And in response, Google gives a bunch of pages that may be relevant, and then people then figure out which of them, by looking at the additional snippets and so on, they will figure out which of them are relevant or not. And all that matters is they come back to Google or this web page, this web search engine again. Okay? And it turns out that somebody who is into full automation might think the right thing to do is first, when people ask a question, have an extended dialogue with them. Try to understand truly what are you really looking for. And then take 3 days and come up with the really good answer. But those search engines don't exist, because that's an overkill. What you need to do instead is something quick and dirty. Now in doing quick and dirty, actually, so for example, what does Google do? It essentially thinks of, most search engines, we'll see next week onwards, that most search engines think of web pages as bags of words. Bags of words. It's like the stupidest model for English text. If I were to tell you that the essay you write, essentially you write this essay in a very nice line-by-line fashion, and then the gravity takes over, all words just fall down into a bucket. That's your essay. Okay, and then I'll compare your essay to your friend's essay, which is another bucket of words. That's what Google does. That's what every search engine does. And you are happy. Okay, now, if I'm going to do bag of words, I could also do 2 other things. I can do bag of letters. Why even words? After you write your essay, then the gravity takes over, all words just fall as letters into the bucket. So you have a bucket of letters, your friend has a bucket of letters. I can do everything that Google does now on the bag of letters model rather than bag of words model. Why isn't bag of letters as good? A different idea is, after you write your essay, they all fall as sentences into the bucket. Sentences, a bucket of sentences, another bucket of sentences. And I compare these sentences. It's obviously better than bag of words. Why don't we use it? The idea is bag of sentences is more accurate but much more computationally inefficient. Bag of letters is very fast but it's useless in terms of accuracy. Bag of words is Goldilocks. Just so. People are happy. Finding those sweet spots is an art form. And understanding where the sweet spots exist in different problems is something that would be interesting. That's a big idea in my view. Okay? So you can just go with the bag of words, but you ask yourself, why didn't they ask? Why didn't we use bag of letters and bag of sentences? Okay. The other big idea is collaborative computing. When there is web, one of the things that we know is there are a large number of pages on the web. But we also know now, even as I speak, there are people staring into their cell phones. There are a large number of eyeballs on the web too. Okay? People might be thinking that they are using web. I can write a web program which uses people instead. Do you see what I'm saying? And I can be very successful. Collaborative computing, crowdsourcing, brain cycle stealing. These are all ideas that are possible because web exists, because everybody is looking at the web. So you can then use that to make them do free work for you. The problem is, typically people don't do free work. That picture, some of you should know. This is Tom Sawyer's picture. And the story, of course, is Tom Sawyer has to paint his wall because somebody asked him as a punishment, you must just paint this entire wall, and he wants somebody else to paint it. What does he do? He makes it look as if it's almost, subliminally enjoyable. He's like, ooh, such nice paint. Do that. And this little kid is saying, my God, you're having so much fun. Can I do this? Can I do this free for you? And pretty soon you see Tom Sawyer sitting, and then the rest of the kids, the bozos, doing the work. You are the bozos when you did the captcha. Okay? In fact, captcha and reCAPTCHA, these are actual scans of old documents which are badly scanned, and people want them to be converted into machine-readable English. Paying money is paying money, a lot of money. You, on the other hand, if I say there's a pretty picture behind this, but you need to first do this translation, you'll be double quick in doing the translation. I got free work. Okay, one other idea is Google wants to be able to do to images what it already can do to words. Google wants to be able to do to songs what it can already do for words. For words, the features are obvious. For documents, the features are words. For images, what are the features? We don't know. If only people put keywords describing the images and say, this one has a tiger, this one has a snake, this one has something else, it'll be good. But people just have the pictures. They don't write what is in the picture because they assume other people seeing the picture know what is in the picture. So what do? You want people to actually write the answers. Now, you can pay them. And there are always undergraduate students who will do this for minimum wage work. Okay? But even that is too costly. What you do instead is you make it into a game. That's the ESP game, where essentially you say, I'll give you points. In the world that we live in, dollars are nothing compared to points. Everybody wants points. Okay? How many points? I want more and more points. So the points, basically, this game essentially says, it'll take two random people. Now, of course, I'll give you points for writing words. Well, yeah, I'll write it, but I know that you're giving me points free, so I'll just make up any words I feel like, whether or not they're actually representative of the image that I'm seeing in front of me. So I will actually devise a more interesting game where I'll say there are two random people who are brought from completely different parts because they both signed into the web at the same time, into this game. And I'll show both of them the same particular image. And free associate, start writing down the words that come to your mind. And whenever you and this other person wind up saying the same word, you both get a point. So, how do you increase your chance of getting points? Tell the truth. If you don't tell the truth, in fact, one of the beautiful things I read once about this book on autistic kid, and the autistic kid basically says, I don't know how to lie because there's so many different lies. Which do I pick? Truth, there is one truth. What happened today? One thing happened today. What didn't happen today? Gazillion, billion, million things didn't happen today. Which one am I going to pick as my lie? So if I make up lies, the chance that I will actually agree with my other guy is zero. So people will be forced to tell the truth. It's a mechanism designed whereby you're increasing trustworthiness of the answers that people are giving. This is used actually in Google image labeling. Louis Wanan actually came up with this idea, and this is used in Google image labeling. And how do you come up with these kinds of games? These are essentially art form, but you're thinking of how to ensure that people who are not paid to do anything for you will still give you right answers. That's another big idea. A third big idea is tapping into the collective unconsciousness. Web has so many pages that if you in fact want to understand the world's knowledge and write it down as a knowledge in a formal knowledge representation language, one idea is to just extract all that knowledge from the web pages. It's our collective unconscious. Okay, which is what I was doing in the last class when I said Martians can actually figure out whether water goes uphill or downhill by just asking Google. And if enough people think water goes downhill, then it must be right. Even though nobody actually got onto Google to write that, oh, by the way, here's a little fact for you. Water flows downhill. Okay? So there's a lot of background knowledge on the web, but you should be able to extract and use it. That's a big idea. So that's what we were showing, which is basically you can answer queries such as water flows downhill, water flows uphill, and then see how many hits. So this was in 2007 when I did this class, and I asked this question. Google said water flows downhill, 25,000 pages say so. Water flows uphill, 864 pages or so. So in 2007, Martian could be sure that with the probability of 25,000 minus 864 divided by 25,000, water does in fact flow downhill. Okay, 2008, 11,300, water flows downhill. 5,220, water flows uphill. Water is really getting aggressive by 2008. Okay? 2010, water actually started flowing uphill. 15,000 pages, water is flowing uphill. And only 11,000 pages, water is flowing downhill. So I went from one idea into another idea. One idea I said is web is collective unconscious. And I got from there to this, which is web basically can completely trip you up. It will make up stuff that doesn't exist. Web indeed is highly, highly adversarial. If you read stuff on web and believe so, I have lots and lots of things I can sell you. Okay? In fact, there are web pages such as Snopes.com. How many of you know Snopes.com? If you don't learn anything else, yeah, this guy is already way ahead of his time. But the rest of you, write down Snopes.com. And the next time your friend tells you, did you know that if you drink Diet Coke, you will die exactly in 7.5 days with this following particular heart disease? And you are about, and please send it to the rest of our friends so that they'll start drinking. Although I don't like Diet Coke, before you send it to the rest of the friends, please go to Snopes.com. And they'll tell you whether or not it's an urban legend. And urban legends are so many and made up every day that there even are pages which actually just track them down and tell you. Okay? So web is adversarial. And if you do some stuff on web and it works great if nobody is adversarial, then you have done nothing. If you came up with a great idea which will work as long as everybody behaves the way they are supposed to behave, throw that idea out the window. Look for an idea which assumes that everybody is out to trip you up. If you do not take adversarial nature of the web into account, most of the ideas you come up with are basically useless. Okay? So those are some of the big ideas. You will see them through the course, but you can also think about them. I'll stop here, starting next class, L4, L5, on Tuesdays undergrad, Thursdays grad students.